Hyundai Rotem's next-generation main battle tank concept. South Korea's Hyundai Rotem has introduced its next-generation main battle tank, featuring new mobility, firepower and protection technologies. South Korea-based Hyundai Rotem introduced its next-generation main battle tank concept, featuring advanced mobility, firepower and protection technologies, at the Eurosatory 2022 fair held in Paris, France. In this context, the design of the new tank is very similar to the Polish-made PL 2013, which was introduced during the MSPO International Defense Fair in 2001. The layout of Hyundai Rotem's next-generation main battle tank, AMT, is the same as that found on every ATM, with a turret positioned in the middle of the hull and the rear of the hull with the driver position. The tank, which has a crew of 3, including the driver, the commander and the gunner, can be operated as manned or unmanned. The new generation main battle tank is based on a capsule-type crew compartment, which allows the tank to be used under extreme conditions with maximum ballistics and mine protection. The hull of the tank also provides a high level of protection using passive and active armor. The tank will also be equipped with an active protection system to repel attacks from guided missiles. Additionally, smoke grenade launchers will be installed on both sides of the tower. The new generation main battle tank is designed to carry 130mm smoothbore guns. It will have stealth capabilities thanks to the integration of all secondary guns inside the turret, which can be installed to perform all shooting operations. The second weapon includes anti-tank guided missile launchers as well as a laser gun. The next generation main battle tank will weigh 55 tons. In this context, the tank, which has a diesel engine, will be able to reach a maximum speed of 70 km per hour. Rubber track technology will be used in the tank, which will have a cruising range of 500 kilometers. The standard equipment of the next generation main battle tank will include the latest generation communication and observation equipment to conduct combat operations day and night and in all weather conditions. In addition, the C-5 ISR will be equipped with command, control, computer, cyber information, surveillance, reconnaissance and high-speed communication systems. While deliveries of the K2 are continuing and the Republic of Korea ordered a fourth batch of that tank, which might receive some upgrades, Hyundai Rotem is looking at the future with its AMBT. One of the key issues is the number of crew members. Currently the tank is set for having a 2-man crew, all housed in the hull, in an armored capsule that should maximize protection. However, a debate is open if such a reduced number of personnel would be able to cope with long-lasting operations. Hence a 3-man crew is also being considered, the human factor being key to an optimized exploitation of technological superiority. The turret will definitely be unmanned and its location, at the rear of the tank, shows that the power pack is located at the front, further increasing crew protection, a solution adopted long time ago on the Israeli Merkava. According to company sources, propulsion might be all electric, based on hydrogen fuel cells, batteries, and 2 electric motors located at the front driving the sprockets. No power indication were provided, but as the declared target mass is under 55 tons, it is safe to say that overall the output should not be lower than that of current MBTs, with the advantage that electric motors ensure maximum torque at all RPMs, hence acceleration will be greater, a key factor when changing position after firing. The company aims adopting rubber tracks, which will allow reducing weight and vibration, increasing Vitronics reliability and lowering crew fatigue. The main armament will be a 130mm high-pressure gun. In Europe, Rheinmetall has been developing a gun in such caliber for some years, and it adopted it on its Panther MBT unveiled in 2022 at Eurosatory. How much the South Korean company talked to the German one is unknown. Republic of Korea tending to develop in-house its systems as shown by the KNIF that adopts a 40mm case telescopic ammunition cannon similar in concept to the one developed by Thai in France and the UK. What is sure is that the main gun will have an automatic loader, considering the crew. However, no information on the number of ready-to-fire rounds was provided. Should the 130mm weapon be developed in Korea, it would be good to at least agree on a common standard for ammunition, allowing multiple source production, which in this very moment has become a key issue worldwide. The model shows what should be an effective thermal sleeve along the main part of the barrel, a solution aiming at reducing the thermal signature, which should be overall considerably lower compared to that of current armored vehicles, due to the electric propulsion. How much the vehicle coating will ensure also radar signature reduction was not declared. However, as in the protection chain not be seen as the first issue, it is quite probable that such solutions will be among the technology R&D currently underway at Hyundai Rotem and other Korean companies. The forward part of the tracks is protected by a series of tiles that might indicate the adoption of reactive armor, the NMBT being fitted with a new generation active protection system of national origin. Sensors fitted on the turret being quite probably dedicated to detect and classify incoming threats. Back to effectors, a remotely controlled weapons station is mounted on the roof in a rear central position, also with a shape aimed at radar stealthiness. It is armed with a 12.7mm machine gun. On the left of the RCWS we find a missile launcher. According to the company, the two missiles installed in a vertical layout will be anti-tank. And asked about the possible adoption of a dual-use launcher capable to fire also loitering munitions, company representatives told DDR Online that this option is currently not being considered. A drone jammer is installed in the roof, while at the rear of the turret a takeoff and landing system for rotary wing eyes was visible, the drone providing the tank crew with situational awareness ahead of the vehicle. It is quite possible that in the coming years the concept will evolve, also according to technology inputs, as the target date for first prototype is 2030. Next generation main battle tank surpasses all capabilities of today's MBTs, providing more efficient mission employment with the latest technologies for the future warfare. As battlefield conditions change, more changes are required to MBT's firepower, command and control, and survivability to be more optimized and to create maximum combat synergy. Hyundai Rotem will proactively prepare for future warfare through development of next-generation main battle tanks that's capable of supplementing combatants' capabilities and function replacements. Peacekeeping is our prioritized goal. The core force of future ground weapons system integrated with cutting-edge technology. Hyundai Rotem presents next-gen K3 main battle tank at Eurosatori 2024. At Eurosatori 2024, Hyundai Rotem, a key player in South Korea's defense industry, is showcasing its latest innovation in armored warfare, the next-generation main battle tank, AMBT, which some observers have already nicknamed the K3. This new tank represents an important step in response to evolving combat scenarios and the South Korean military's demand for improved tactical capabilities. The AMBT follows a traditional layout with a driver's compartment at the front, a centrally located turret, and a rear-mounted powertrain. What sets it apart is its innovative crew configuration, a three-member crew, including the driver, commander, and gunner, all housed in an armored capsule located in the forward hull. This design aims to enhance crew protection by isolating them from potential threats posed by autoloaders and ammunition storage. At the heart of its firepower is an unmanned turret armed with a remotely controlled 130mm smoothbore cannon, capable of engaging targets up to 5 kilometers away. The tank is also equipped with multi-purpose anti-tank guided missiles, ATGM, with a range of 8 kilometers, including advanced modes for line-of-sight and beyond line-of-sight engagements. These capabilities are complemented by a remote-controlled weapons station on the turret, accommodating weapons ranging from 12.7 to 30 millimeters. Defensively, the AMBT is equipped with a suite of advanced technologies, including a directional infrared countermeasures (DIR) system to thwart heat-seeking missiles, an active protection system (APS), and a drone jamming device. Its low-profile design and reduced radar and infrared signatures make it exceptionally difficult to detect on the battlefield, reminiscent of the Polish PL-01 tank. Armor protection is paramount, with a modular system comprising steel, ceramic and composite materials. This includes very high-hardness armor plates, oxide-free ceramics, and reactive armor modules capable of withstanding large-caliber kinetic and chemical energy projectiles. The tank meets STANAG 4569 Level 4A/4B standards for mine protection and is further enhanced with stealth technologies, including RF and infrared camouflage based on metamaterials. On the mobility side, The EMBT is powered by a diesel engine, offering a top speed of 70 km per hour on the road and 50 km per hour off-road. Its rubber tracks reduce noise emissions, contributing to its stealth tactical capabilities. With a combat weight of less than 55 tons and dimensions optimized for agility, less than 10.8 meters long, 3.6 meters wide, and 2.4 meters high, the tank offers an impressive operational range ranging up to 500 kilometers. Technologically advanced, the EMBT integrates AI algorithms for complete situational awareness, a combined manned and unmanned system, and XSR, command, control, communication, computer, cyber information suite, surveillance, and reconnaissance, robust with high-speed satellite communications and connectivity capabilities. Hyundai Rotem's EMBT represents a formidable addition to the modern battlefield, integrating cutting-edge technologies with enhanced protection, firepower, and mobility to meet the rigorous demands of 21st century warfare. As it debuts at Eurosatory 2024, it is poised to set new benchmarks for armored combat systems on a global scale. On October 23, 2023, Hyundai Rotem, a subsidiary of Hyundai Motor Group, announced the development of the K3, the world's first hydrogen-powered battle tank, in partnership with the Agency for Defense Development and the Korea Research Institute for Defense Technology Planning and Advancement. This tank is designed to enhance the capabilities of the Republic of Korea while meeting global energy sustainability goals. Equipped with hydrogen fuel cells, the K3 is expected to replace the diesel engines in current tanks, such as the K2, offering quieter and stealthier operational capabilities. The collaboration between Hyundai Rotem, the Agency for Defense Development, and the Korea Research Institute for Defense Technology Planning and Advancement represents a significant technological breakthrough, moving the country closer to adopting hydrogen-powered vehicles in military applications. The K3 is expected to be equipped with hydrogen fuel cells, advanced electric motors, and rechargeable batteries, providing an environmentally friendly alternative to diesel engines. This innovative system not only reduces emissions but also allows the tank to operate in near silence, greatly enhancing its stealth capabilities, an essential strategic advantage in modern warfare. The anticipated design of the K3 offers substantial operational benefits, including the ability to navigate difficult terrain and steep inclines. In addition to its hydrogen fuel cells, the tank will feature a 130mm smoothbore gun, a significant upgrade from the K2's 120mm gun, enhancing its firepower. Hyundai Rotem has also revealed plans to integrate artificial intelligence, AI, into the tank's fire control system. This AI-driven feature aims to improve the K3's targeting and precision capabilities, giving it an advantage in preemptive strikes and rapid threat assessment on the battlefield. Production of the fully hydrogen-powered K3 tank is targeted for 2040. As an interim solution, Hyundai Rotem will first introduce a hybrid model, combining diesel and hydrogen systems. This transitional phase will allow the South Korean Army to benefit from some of the advantages of hydrogen technology while preparing for a complete shift to this energy source. Hyundai Rotem officials have confirmed that this hybrid version will be operational soon, supporting South Korea's strategic objectives with reduced emissions while maintaining robust military effectiveness. The development of the K3 tank aligns with a broader trend toward hydrogen fuel applications in the global defense and transportation sectors. Hyundai, already recognized for its pioneering work in fuel cells, is extending its expertise into military technology, contributing to the evolution of hydrogen-based mobility solutions. For instance, the company has previously collaborated with China's WeRide on hydrogen-powered autonomous vehicles. Similarly, in the United States, advancements in hydrogen technology are making waves in commercial and military maritime transport, with projects like the Sea Change, the first hydrogen-powered ferry approved by the U.S. Coast Guard, set to launch soon in San Francisco Bay. A hydrogen fuel cell operates by converting hydrogen and oxygen into electricity, water, and heat through an electrochemical reaction. It consists of three main components: an anode, a cathode, and an electrolyte. Hydrogen, stored in a tank, is injected into the anode, where it splits into protons and electrons through catalysis. The protons pass through the electrolyte to reach the cathode, while the electrons, unable to cross the electrolyte, travel through an external circuit, generating usable electric current. On the other side, oxygen, typically drawn from the air, is introduced at the cathode, where it combines with protons and electrons to form water, a clean byproduct of this reaction. This technology, emitting only water and heat, provides a sustainable and pollution-free energy source, ideal for applications requiring low acoustic and thermal signatures, such as stealth military operations. In a conflict like the one in Ukraine, a hydrogen-powered tank would offer significant strategic advantages, notably in terms of stealth, autonomy, and operability in hostile environments. Due to its low thermal signature, a hydrogen tank would be harder to detect by infrared surveillance systems, facilitating discreet maneuvers, night patrols, and infiltration behind enemy lines. Its increased autonomy would also allow armored units to penetrate deeper into enemy territory without frequent refueling, a valuable capability in areas with complex logistical supply chains. Additionally, producing only water vapor without polluting emissions would make the tank resilient to degraded or contaminated environments,